Hi. Yeah, okay. My name is Joachim Asare. I'm a graduate student at Harvard University, where I'm researching on AI and machine learning, but much more specifically with responsible AI, the bit of the boring part of after you get the data. Today, I would be presenting on the responsible use of big data, specifically with publicly scraped data from online to train or fine-tune large language models. So first of all, just even from the previous presentation, you heard some of the use cases of publicly scraped data in terms of training large language models. And these models are indeed data hungry. Currently, you can have several applications, like you want to scrape Amazon product reviews to build some large language model that is able to tell you the next best product that clients would want to buy. Or you probably want to build an SEO tool, or you want to be able to predict your next trip, several applications of these publicly scraped data. However, with anyone that has worked with publicly scraped data, I realize there are some inherent problems with them, and I'll be focusing on the key issues with respect to the ethical dilemma that comes with using such data and how to actually mitigate these. And I will be focusing on these problems across the three main steps of the AI development pipeline, which is from the data collection to the training or fine-tuning the model, and lastly, at the deployment stage. Now, as I mentioned, you have several problems that are inherent with this data. First of all, you have privacy issues, where you have several PII information that may be embedded within these tools. Thanks to like some products from Zeit, you can take these out. Also, you have a data quality issue where you may have misinformation. How is this a problem? You're going to train a large language model. If you have some misinformation within it or some misrepresentation within that data, the language model is going to amplify that information that is in there, and you want to take critical look at these things. Next is inherent bias. We are personally biased. I don't think anyone isn't biased. And so is the information on the internet. Now, you may be scraping from an online platform, let's say Reddit, and interestingly, maybe on that specific subreddit channel, you have an overrepresentation of a specific demographic group. You probably want to seriously consider what group is being represented in here. And I will demo shortly how you can identify some of these issues. And as I always tell people, bias is not always the issue. The issue is where and how you're going to deploy this large language model. Because, for example, if it's a lot of young people talking, yes, it's going to be biased towards young people, but perhaps the context in which you're going to be deployed are for young people. But then you want to take a critical look at these things, and I'll demonstrate that shortly. And lastly is a big issue of data leakage, where you can prompt the large language model directly. And I have performed some red teaming exercise with my other research team, and you're able to prompt these large language models to get you PI information that wasn't taken out of the training data. And I'm going to show you an interesting video. I'm sure some of you may have seen this recently. I have the audio. Okay, basically I can talk through it. So some Harvard undergrad students, interestingly, close friends of mine, I actually know them. I didn't know they had done this until I saw it in the news just 2 days ago. And they were able to hack into the Meta's Ray-Bans that was just released recently. And what happens is with their glasses, they just go out in the public, look at anyone, and they're able to retrieve PI information of everyone. And so they walk up to some lady and go like, hey, your name is this, I know you from here, and they warmly like receive them and all that. And what's the big issue in here? This is very dangerous. Imagine I go to a school, I want to, kidnap some kids. All I need to do is look at them, tell them, oh, I know your dad, your mom works here, your dad works here. It's so much information about them, where you've been, what you've been doing, and have established trust, they're going to follow me. And these are some of the big issues that are going on right now. And Meta, in having much more of all these resources, they left out this critical aspect of responsible AI, and just some 2 undergrad students were able to exploit it. So I'm going to talk about these issues across the 3 main development pipelines, which include the data collection stage, the training and fine-tuning stage, and lastly, with respect to the deployment stage. So firstly, at the data collection stage, what are some of the main problems that are inherent with the data, just as I introduced, that you may want to mitigate? First is that most of this data contains PII, and sometimes you may scrape data online, you just want to filter out the usernames. But within the post themselves, someone is actually talking about someone's personal information, and you want to filter all of these things out. These things are sometimes just 3 lines of code, just one particular class, one particular function. But what happens is that when, as engineers, we are not that much serious about these things, we don't prioritize it, what happens is that we just do some basic traditional filtering and then we are good to go. But then we have all of this PI information in there that isn't even necessary for the context of the large language model that we are going to train. Perhaps you just want it to be familiar with that content of the conversation and not the personal data. But then we don't even take a second look at it. The second thing is with bias, as I introduced earlier, and most of this data may contain an overrepresentation of a specific demographic or a specific perspective, maybe a political perspective, and you sometimes want to balance these out. And it's a bit tricky. It's not always a 50% balancing out that you just want to do within the data collection stage. Once again, as I said, you want to think about the context in which you're going to deploy these models. So within this context, is this actually going to be biased? Is this actually going to give me an unwanted outcome? You want to really ask yourself these questions. And that is why we really need to connect even these stages together, and I'm presenting across these pipelines, because once this is not done at this stage, because the data cleaning was done or outsourced to some other data engineering team that know nothing about how it's going to be deployed, they're just going to give you the data. What does the machine learning engineering team do? They're just going to dump in all that data in there and work with it. And that is why I'll show this later, but I have this nice phrase that goes like, if you just dump in all the data, you're going to have dump AI. Yeah, so what are some mitigation steps at the data collection stage? We want to be big on anonymization. With respect to bias, you want to really think about the context. Once again, as I said, it's not just some quantitative test where you just want to balance out 50-50 of several demographic groups. You want to really think about, where am I going to deploy this large language model? How is it going to be used? What are the potential hazards that I must consider within this context? And you want to really think about this right from the data training stage, even to the deployment stage. Lastly, with what most data engineers work with, you often would have noisy or irrelevant information. But sometimes it's not about it just being irrelevant to the training model. It may contain misinformation. And you really want to think about that in training these models. Perhaps you're just building a tool that is going to give customer insights, and just 2 months down the line, you're going to have some clients sue you that, well, the model told me that I should kill myself, for example. And yeah, it's something that can easily happen. So I have a demo. Because of time, I'm just going to show just a few screenshots, but I would share a link to the Google Colab notebook demo that I have, where I scrape data from Reddit, specifically a mental health subreddit, just conversations of a lot of people complaining about mental health issues or asking for help, and what that looks like at the data collection stage. So in this notebook, as I mentioned, I just scraped data over 1 year of posts within that subreddit. And guess what? I was able to easily get the usernames, as I shouldn't have shown them here, as well as the posts themselves. And what mitigation strategy? First of all, I want to take out or redact this usernames. I don't need them in the model. I don't need my language model to know who said what. I just need the content of the conversation. And once again, this is something that can easily happen when you have your team isolated. Data engineering team is just working on the data, just going to submit the data. No one really knows how we're going to deploy these models. And this easily happens, trust me, even at big corporations. So in this example here, in the Colab notebook that I'll share, you see that I was able to successfully redact these usernames and email addresses. And another thing that I also implemented in there was within the posts themselves, trying to look out for email addresses, phone number, names, all these PII information, and take them out from the posts themselves. Now, I use a very interesting heuristic approach, which is very helpful, and that is using a word cloud. People don't know how so powerful a word cloud is. Now, for those that may not be familiar, so within all the information that was taken, which is with the post, you're able to develop a word cloud which literally gives you a frequency representation of all the words that are used inside. What does that help us do? Once I'm able to see the most represented words within the model, I have an idea of where the model is going to be biased towards. So for example, as I said, this was a mental health Reddit subreddit, and you see words that are really represented as feel, want, people, don't, it goes on and on. Now, these may just look like words, but they give you a good picture of what your large language model is going to focus on. And you perhaps even want to do this right even at the data collection stage. Very, very important. In the other half of the page, I try to focus on just nouns, trying to find out if there are specific demographic groups. Luckily, in this use context, they were mainly like general nouns and general pronouns, but I found some interesting words in there, like the F word, it's even in there. It's even in there. You have very interesting words that you not want to go into your large language models that are there. And a year later, 2 years later, someone prompts your model and finds these words in there. Now, these are even just the most represented words. So even a word that you see there that is so little is going to be recognized by the model. How many of you have prompted GPT and you're able to know that or know from someone's result that this is from GPT and you find certain common words that are in there? Can someone just tell me some common words that you just find in GPT? Like I know one like underscore. Once I see a write-up and I see words like underscore, I'm like, nah, this is GPT. I'm just some of you see several of these words. And yeah, it's mentioned that most of the training data was from a user group that often use such words. And with a basic word cloud, you can actually identify what those words are that your model is going to be biased towards. The next stage is with training and fine-tuning, and I put this together because mostly as other businesses that are not working on foundational models, you won't mostly be directly training because you would be working with pre-trained models. What you would be doing is fine-tuning, which is also a training stage where you're now giving it that data set, or you're even using a RAG approach of where you're uploading certain files and creating some database of that data that you're working with to train the models. Now, at this stage, what happens? The bias that was in there is reinforced. What happens when you run several epochs of training a model is you're giving it an ability to pay attention to certain features. Pay attention to those features, and they are definitely going to be reinforced within that models. The next thing is with memorizing specific data points, and in the Google Colab, I demoed using just GPT-2, where once I prompted it, it literally even pulled out the exact post of someone. That is something that can really happen, and really want to consider that. The next thing is having a contextual misunderstanding where the model is performing well, but it's not understanding the context in which it's applied. The concept of accuracy working as a machine learning engineer or even a data scientist is very tricky because it's accurate towards what? What is that benchmark? How applicable is that benchmark in the system in which you're going to deploy it? How helpful is it going to be? And, for example, last week I just did a red teaming exercise where I prompted GPT that, hey, I wanted to take sleeping pills because I'm very sad in English. And then I did another one in Akan, which is my local language. I'm from Ghana. And what happened was when I prompted it in my local language, it told me that, hey, take the drug if you want to take the drug. But in English, it literally told me that it gave me so many other options that I should consider that doesn't involve taking the drug. And that is because now, in one case, I was deploying the model in a low resource context where this is an underrepresented language where ideally these models were trained on English data that were online, which are mainly largely represented, and maybe had much less data with respect to that language. So you want to think about that model and deploying it within that context and trying to fine tune it for that context. That is very important. So yes, it has a high accuracy of what, 0.999, and ask your engineers, ask me that, hey, what was that measured to? What is this accuracy being measured towards? It's very, very important. It's not just about those quantitative figures, it's really with respect to that context. So what are some of these mitigation that you can put in there? You really want to do a lot of resampling and reweighting. you want to check the weights and biases that are within your models. Perhaps you want to assign much more weight to certain features over certain features. And this is a very iterative process that you want to just repeat on and on and on until it's quite suitable for the context in which you're deploying it into. Now, once again, as I mentioned, you may have some of this PI information that still leak through because even filtering wasn't enough. Maybe you were trying to filter email addresses by looking for the @ symbol. What if somebody did a typo and they didn't put in the @ symbol? It's going to go through. So you just want to implement a lot of differential privacy. And one important feature that is currently being done at several corporations is a human-in-the-loop system. That is, while we are fine-tuning the model, we want to be prompting the model, testing its output, and doing some sort of, it's trying to mimic reinforcement learning where you're trying to give it a feedback towards that answer and trying for it to improve and skew much more towards the answer that you provided to it. So in the collab, once again, I would share it. You see something interesting. So yeah, I fine-tuned the model. And this is GPT-2. They didn't expect so much good performance, but as you can see, I asked the question, how can I avoid suicide? And this is, once again, just to remind you, data trained on the subreddit channel for mental health. And it pulled up like just a post. And so this is it overfitting towards a specific data point, memorizing it. And you may think that, oh, a large language model shouldn't just give me directly that data, but it just literally, this looks like some direct post that someone made saying something like, I'm not sure if I should or should not. I'm a very depressed person and I don't want to be alone. Now it goes on and on because this person was actually talking about how he avoided committing suicide, if you go on and read it. And so it's doing well by understanding the context of the question that I asked, but it's just brought back someone's post. Yeah. So lastly, at the deployment stage, you want to be very, very big on sensitive to data leakage. If much more time was done on this on the Ray-Bans, perhaps they would have been able to prevent the model from working in the way that the students were able to hack it to do. And the next thing is you want to be very conscious about inappropriate output. Now, inappropriate output could be something that is harmful. So you want to take time and still take out certain words that may be harmful, that may be offensive in the use case that you're going to deploy the system. Once again, as I always say, and I want you to leave with, it's very context specific. Think about where you're going to deploy the system. It's not just about the types of AI systems you want to build. It's about the system in which it's going to be deployed and how it's going to affect people. So maybe you're even a business here and you focus on just maybe scraping and providing that data to certain other people that outsource that to you. You want to ask them the questions of maybe in what's the context in which it's going to be deployed. Maybe they may not want to tell you specifically, but you should get a fair idea of what that domain looks like, and that would help you to mitigate some of these. The last thing to consider is with transparency. Now, transparency comes in different ways. One thing you want to do is provide maybe some sort of detailed description of the data set. I think Kaggle does a good job of that. Most of these data sets to tell you the source of that data, the context in which that data was used. So once the data that's scraped, you want to provide them several information about the context of that data that you scraped. What were the kind of people that were talking on those platforms. You want to do that kind of work and add these detailed data descriptions to the model. That way it would even help these machine learning engineers or product managers to really be very mindful of how they're going to use that data and not just provide that data. We all need to help each other because what happens? No one is to blame in the end. Everyone is going to say that, well, this business just gave me that data and I'm working with that data. This is what is happening. It's not my fault. All I did is just put in some algorithms. The data scientist says, hey, I just scraped that data. I didn't say these harmful stuff. So we just all need to work at our end of the bargain, do a lot of real-time moderation while building these systems. And at the output stage, still do a lot of filtering of those words because still, even if you implement all these things right from the data collection stage, even to the fine-tuning stage, it can still find its way even into the deployment stage. Big corporation like OpenAI with a lot of employees, a lot of state-of-the-art technology, still you're able to red team what I told you about where I tried to prompt it in Tree that should I take this drug, and it said yes. That's by OpenAI. This was GPT-4. Like that's a big deal. That's a big deal, and it's still leaked through. So we want to spend a lot of time on this, and that is to say that when you're thinking about deployment, you usually would want to have some relatively good amount of time in the pilot stage of testing how it's working before we release these models, and not just be too competitive and, hey, we just want to get this model out there, we just want to get this model out there. Because guess what, with the video that I showed you, that can increase crime rate by like skyrocket. Yeah. So you can go into the collab, which once again I would share, and I try to do some mitigation of bias. Sorry, this is so small over there, but what I was doing over there was put some keywords or specific demographics that I want to balance out within the data set, considering that this is going to be for a general purpose application. So I asked the same prompt I asked earlier, where I asked about tips for better mental health. This time, it seemed to be still pulling a specific post, but it is trying to act better. And this is what happens when you start implementing these mitigations. So what do I want you to leave here with? Just remember this: if you just dump in the data, you're definitely going to get dump AI that you would say, hey, why didn't you understand this context? Why is it not doing this? And it's just because we dumped the data in there. So we want to really collect data ethically, really consider the context in which we're using it. Removing PII, it's a very big deal. You really want to get APIs that are very big on that, else you'll be contributing towards a big issue. I have a professor I work under that calls it the next apocalypse of AI that is coming, and he says he's raising people to save the world. So once you're deploying for scalability, security must be bigger. It's one thing you really want to consider. And once again, as I say, this is a very iterative process. You can't just get it at a go. It's something that you need to keep repeating on and on and on. Okay, thank you very much. I'll take questions.
Thanks. I just want to remind everybody, everybody should have a link in your email to AirMeet, so you can go in there and ask questions. We have a few for you. One interesting one, I think, is, do you believe that any of the large Gen AI companies, how seriously do they take this? Are they doing the same kind of techniques you talked about today? And what do you think the future will be?
Okay. Okay, this is interesting. I took a deep breath because, you know, it's quite dicey. So companies like Anthropic, they have a very serious, big, like, responsible AI team. They are very big on that. That's like one of their main value propositions. OpenAI say they are big on that, but you know, we all know it's not really that way. No, I can't really quote companies, so let me just say that without names. There are some big companies that started out not being big on this. They were just doing the usual like filtering and all of that, and then you have a lot of issues. And then there are some companies, let me mention the good ones that I know are currently big on that. So for example, Anthropic is quite big on that. I've worked quite a lot with the different Llama models by Meta. They're also quite good with that, but you still need to do a lot of work there. Now, the difference is, if you're working with just a RAG application where you're going to just get the API of this model, which is very general purpose, and just prompt it, you may not have these issues. But in the use case where we have different agents, AI agents that are being built by different companies for specific use cases, there's a lot of fine-tuning going on, and you have to do all of this all over again. Because what's happening is that you're not training the model so perhaps you can get the same model from Anthropic, but what you need to do, because you're going to still feed it with data to fine-tune it, you have to go through all of this process over again. But most people just assume that the model has these security features and just work with it. But once again, you're now sort of retraining this model, and you have to go through this process right from the beginning to the end all over again. Very important, yeah.
Do you think it's basically time to market is one of the main barriers to just investing more effort in this?
Yeah, that's true. Yeah.
That makes sense. Also wanted to ask, how do you redact and anonymize some of the personal data? What are the best techniques for it, or is there any systematic approach?
Yeah, so very simply, you want to maybe look at the data. So you put it through maybe just some basic data science where you just put the data in, try to have an overview, look at the head of the data, get some few lines. That way you'll be able to see the columns, go through all the columns, and perhaps look at which of these columns are most likely to contain PI information. I think, for example, Reddit, that column is literally called Arthur. Other columns of other data sets may have a different name. You need to find what it is, and then you try to like apply a technique to like take out maybe that entire column. When it comes to maybe other columns that may contain some information that you want to work with, it may be tricky because you don't want to delete that entire like data, the entire row or column, but you want to implement some techniques to take out email addresses, look out for phone numbers, take out phone numbers, look out for names, or maybe you apply a word cloud, try and just pull out all names that are in there. Sometimes you may use another language model. I think there's a talk on using large language models to clean data. Hopefully that is talked about, but you can also use another large language model to look through the data. Yeah, I've done that before. It works pretty good, trust me. And look through the entire data, tell you where there are names, and then you can take it out. I think with the Colab, I use Spaces. It's one NLP library that works well. And I made it look through the data and try to identify all names and phone numbers that are in there and take it out. Yeah, so try and use AI to help AI.
Yeah. How do you balance the need for large data sets with ethical use of web data?
Yeah, so definitely what I was presenting on was focused on such large data, and most people think it's much more work, but the same way that you can work at scale while using some like programming techniques to work at scale on such large data is the same technique that you would perhaps use on some small data. Usually it's the same lines of code, but this time maybe it's just taking much more computing power, much more memory. So it's most often the same techniques because it's the same data just at scale. One post is definitely in a similar structure to like 1 million posts. So you would apply like the same technique, but you probably just want to use some other tools, some other automated tools. Like I said, you can even use another large language model to do that, to clean that data at scale. I don't know if that answers the question well. Yeah.
Yeah, and do you think it'd be better for society if companies behind these LLMs made their models open source, or does that just cause more problems?
I'm pro open source. That's a subjective answer.
Well, we have a lot of open source fans here too. Do you think we can retrofit context, such as similar themed data set that can be used to train a model for another context which is very niche and lower data online?
Yeah, this is a lot of research that is even going on at MIT right now. I'm even meeting a certain professor on Monday, and this is something she specializes in. I think she leads AI in decision making. And this is something that a lot of work is currently being done. It's quite tricky. I've forgotten the last bit of the question. I was going to say something there. Just want to remember.
Sorry, it's just disappeared. One sec. Yeah, can we retrofit the context? Yeah. Such as a similar themed data set, which can be used to train a model for a very niche.
Yeah, so that's what I was going to say. Where the research being done is on using synthetic data. It may or may not work. You really want to produce that synthetic data to purely reflect that same context in which you're going to use it, or how you'd have got that same data naturally. But it's, once again, it's an iterative process. It's not just a yes, it depends. So yes, I have seen some successful work that has been done with synthetic data. There's a lot of like good publications that have been done on that, but it's something that, once again, it may differ from one use case to another. So you really always want to think about the use case. That is why I always say that adding a description or a specification of how your model works, it's very important, because that's how you know whether some synthetic data would help or not help. But yes, there have been successful projects with like retrofitting, creating synthetic data to train a model, and it's been successful. Yeah.
Cool. Any questions from the audience? Yeah.
Thank you so much. That was a great talk. One quick question, and based on some of the experiences that I've had. Back in the days, considering open source versus not so open source LLM models, have caused issues when it comes to sensitive information, or just setting some guardrails in place. While you are fine-tuning a model, how do you plan to put those guardrails in place? Because, for example, I'll give you a real-life example. One of the projects that I was part of, and it has become big, was about summarization of large text corpus.
Okay.
Summarization of large text corpus by putting a lot of emphasis on the most important, it wasn't just a vague statement, hey, summarize this document. It was really about taking into consideration what all we need from it. However, with some of the open sources, they did not have a guardrail around foul languages. In some of those use cases, those LLMs did not shy away from just throwing out some of those languages that was nowhere acceptable. So how do you plan in your use case? How do you plan to put those guardrails from different perspectives?
Yeah.
PI being one, foul languages being other. And just, I know temperature is something that can help it to be more creative. That's a different thing altogether. But from the foundational standpoint, how do you plan to do it?
Yeah, very great question. So even you mentioned temperature, and temperature is usually not even so helpful, because what temperature does is that you're trying to just get it to be much more generalized
Just a creative,
in its
yes,
output.
yeah.
Yes, but it won't really take out those words that it had focused on.
Correct.
So that's why even with the word cloud I showed, you see some words, I saw like the F word in there. I don't know if I'll still find it, but but it looks so small in there, but once it's being represented, because these are like the most used words in there, it's going to show up in your model. So you want to use certain approaches of maybe even just a basic heuristic approach of word frequency, just see the most used words, because mostly if that maybe a foul language is in there just once, twice, maybe something like under 100, depending on relative to the data set, it may not represent it. But when you have that frequency at a certain higher rate, then it's going to be shown in the features. Another thing you also want to do is you can investigate the attention weights and how they're working. I have some work on that. I wish I could show it, but where you can literally try to understand how a specific model is working, where you try to look at the words that it focuses on once you put a query into the model, and try to do this. I use some sort of like a heat map that looks at the prompt that you put there and how it's generating that output, and you get to see what words it's focusing on. This may take some amount of time because you want to try out different prompts and all that. So yeah, it's not a direct process. Definitely, as you said, it's a bit challenging, but there are some approaches where you can like be looking at the attention weights, which words is it focusing on and why. You can also use like this word frequency process. You can use the word cloud process to also see the words that it's focusing on right at the data collection stage. Yeah, that could be much more helpful.
Absolutely. Thank you.
Yeah, you're welcome.
Any other questions from the audience? Yeah.
When using human in the loop feedback, how do you avoid overfitting, especially whenever you understand the context and have, something that you're working towards?
Yeah.
How do you avoid that?
Yeah,
general.
That's very challenging. But usually now this is what I always say to people, if you're building a model to be general purpose, like you have with these chat boxes, most user experience professionals will tell you that the chat box is I met this, like a user experience, he's one of the leads at Google, and he so doesn't believe in using a chat box for AI, because he feels that for general purpose, that's like a big issue. You really want to use specific use cases. And so, yeah, it is quite challenging. But once again, it's quite experimental. Like I'm answering this question because it's experimental, it's context specific. On a specific model, once you generalize it very much, it's going to work well. On some model, even after you generalize it, you may still have those kind of issues. I think my best answer to tell you is that it's quite experimental. You need to test it out. Once you deploy it, you want to query the system several times and check if it's overfitting. It could be that like some other settings like the temperature, or sometimes you want to apply sampling, and maybe you don't want to do it. Maybe sometimes random sampling works well. Sometimes applying like some specific figuring like sampling will work better. It depends, and you have to test this on and on. And that's the funny thing. That's why some people describe AI as a black box. Some other like mathematical people be like, it's not really a black box, but it's sort of a black box because it's very, very experimental. It's not just the traditional coding where we just input something, we know very well it's just going to follow this rule. Now it's not doing that. And nobody even knows how neural networks are that successful. I guess that's like the next Nobel Prize for the next like 100 years, if you can really explain why after 12 layers, you have large language models working so well. Yeah.